are solving exponential equations, what are we looking for?
Common base.
The common base, yes. Thank you, Jack. You make me feel like I actually taught something. Unlike Mason, who makes me feel like I'm speaking a foreign language. But what do you mean there's no base?
Like they're both
The 2 is the base. This is the base. Base, base. Now you know. Okay. So since they have the same base, we set the exponents equal. I mean, if we reason through it, right? If we say that 2 to the power of something is equal to 2 to the power of something, those powers have to be equal. Makes sense, right? So x has to equal 8. Boom. We're done. Okay, next one. What are we going to do? Yeah. 4n plus 5 equals n minus 7. So let's say that's 3n plus 5 equals negative 7. So 3n equals negative 12. So n equals negative 4. Boom, we're done.
Wow.
See how easy? Whoa. Okay, getting a little harder. What do we have to do now?
add the k's together.
Yeah, so simplify this side first. So this is written as 3 to the k plus 2 equals 3 to the 5k minus 1. So 3 to the 2k plus 2 equals 3 to the 5k minus 1. Does everybody understand how we simplified it? Is everybody okay? Get it, K? All right. So, I
That's
don't
like
know.
that trig analogy.
Yeah.
Jack said.
Jack is very clever. Okay, we're going to add 1, so we get 3. We're going to subtract 3k, so we get 2k. So k equals 3 over 2. Boom, we're done. It's good, yeah? Yeah. Number 10. Whoa, it just got harder. So we're going to add the exponents on the left because we're multiplying with the same base. So we add. So that's 10 to the 5th equals 10 to the, we're going to add the exponents again. V plus 4, 2v minus 11. So we get 3v minus 7. So 5 equals, which one? Hey.
One before that is
number 3. I'm pretty sure it's wrong.
Yeah, I think it's 1.
It's 3k equals 3.
Yeah, it should be k equals 1.
3k plus 2 equals 5k minus 1.
It's 2k, I believe, at the beginning.
Oh, I copied it wrong. I hate that when I make a mistake because it makes me look so dumb. Okay, 2k. I was just testing you.
Oh.
I was testing. Good job, guys. You caught it. Good job. Okay, so k equals 1. Kind of ruins the whole boom, we're done thing, doesn't it?
It's just make sure check your
Check my work. There you go. All right, so we get 12 equals 3v, so v equals 4. Good? Okay, so moving down. Guys have a problem? Question?
You're arguing about
We're arguing about this.
Okay, so what are we going to do on number 5?
36 equals 6 squared.
Yeah, rewrite this as 6 to the 2nd. We have the same base now. So 2x minus 10 equals 2. So 2x equals 12. So x equals 6. Right?
Try it.
Okay, number 6. So we've got, yes, ma'am, sir?
Do you just forget about the base then?
No, you can change the base.
We're not forgetting about the base, but logic tells us.
Do you just, is that your answer? You just don't put the base in there?
Yeah, because I'm trying to find the value of x. Yeah. Yep.
Oh, I see.
Okay, so we get 2 to the p minus 7 equals 2 to the third. So p minus 7 equals 3. Adding 7, we get p equals 10. Right, so we're trying to solve for the variable, right? All right, number 7. 7 to the 4x plus 11 equals 7 to the negative 1. So 4x plus 11 equals negative 1. So 4x equals negative 12. So x equals negative 3. Just put more paper in my printer in a second.
Now what do we do?
I didn't see it. Anyway. Hopefully just get something else.
Nope.
What did you do?
Okay, number 8. So how are we going to write the 32? 2 to the 5th. Look at you guys. You're so smart. So that means 5 equals 2m minus 9. Adding 9 to both sides, we get 14 equals 2m. So m equals, what is it? 7. Boom. Number 8. Wait, is there no number 8? That was number 8. Number 9. Okay. So 27 is 3 to the third. So I'm going to put that in parentheses because that whole thing is risen to the 2x plus 6. Okay. Now we have to go do what with these exponents? Multiply them. So this is 3 to the 6x plus 18 equals 3 to the 2x. So that means 6x plus 18 equals 2x. 4x equals negative 18. Is that correct? Let me just double check my work. 3 to the third, 2x plus 6, so 6x plus 18. Okay. X equals negative 18 over 4, or x equals negative 9 halves. Okay. Is there any way I can check this? I could plug it in, or we can use our calculator, we can graph it, right? So we can put this in as y1, and we can put this in as y2, and calculate the intersection. So let's do that. Just because we want to do it, and it's fun, because math is fun. Okay, so this was 27 to the power of 2x plus 6. Right, and the other side is 3 to the power of 2x. Okay, and we're going to zoom on a standard window. And we're going to calculate where it intersects, and that's really hard to look at. So let's, sorry. So we're going to do a calculate intersect. Right, and first curve, it's defaulting to the first curve, so press enter. And it defaults to the second curve, and I'll press enter. And I'll just press enter on the guess. And sure enough, x equals negative 4.5, which is negative 9 halves. Okay. Quick way of checking our work. Okay, number 10. See, we've got 4 to the y plus 2 equals, now 16 we're going to write as 4 squared, and that whole thing is risen to the y minus 3. So we have y plus 2 equals 2y minus 6. Adding 6 to both sides, we get 8. Subtracting y, we get y equals 8. Dun, 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 dun. We good?
Yes, we're even.
How are we doing?
Fine.
Are we happy? Is everybody happy? All right. 125. What are we going to do? 5 to the third. And 25 is 5 squared. So we get 3y equals 2. So y equals 2 thirds. Be careful because some of you probably did like 25 to the third, and that's not true. Okay, I am going to let you spend, there's no surprises here. I'm going to let you spend the rest of the period work. No, let's do it together. Never mind, we'll do it together. And then I'll give you a homework worksheet. 16. 4 squared. Whoa, that's not going to help me though, is it? Because I can't write the 8 as a 4, right?
It's gotta be 2 to the power.
Yes, it's got to be 2 to the power of what?
4.
There you go. 2 to the power of 4 to the 3x equals 2 to the power of 3 to the x plus 2. So we get 12x equals 3x plus 6. Does everybody understand how we got that? Okay, subtracting 3x, I get 9x equals 6. So x equals 6 over 9, or 2 thirds. Okay. Okay. Same thing for number 13. I have to write it as a power of 2. 2 squared to the 3x equals 2 to the third to the x minus 1. So we get 6x equals 3x minus 3. Subtracting 3x, we get 3x equals negative 3. So x equals negative 1. Okay. Question so far? Okay, how about 14? 81 is 9 squared, but has to be a power of 3 because I can't write 1/3 as a power of 9. So 3 to the 4th is 81. And then 1/3, that's 3 to the negative 1. Okay. So we get 8x plus 20 equals negative 2x. If I subtract 8x from both sides, I get negative 10x. So x equals negative 2. Am I going too fast? Okay. All right, let's look at number 15. So what power am I going to use for number 15? 2. Okay, what's 8 written as a power of 2? Okay, so it's 2 to the third to the 2a minus 1. And then 32, that's going to be what? 2 to the 5th to the power of 2a plus 1. So when we distribute this exponent, this becomes a 6a minus 3 equals 10a plus 5. So let's see here. I'm going to subtract 10a, so I get negative 4a. And we'll add 3, so it equals 8. So a equals negative 2. Okay, dokie? Okay. What am I going to write the 27 as? 3 to the third, yes. How about 243? There you go. Okay. So we get 6x equals 5x minus 10. Subtract 5x from both sides, so we get x equals negative 10. Okay. Good. Okay, 17. So I base 4. Can I write 64 as a base 4? 4 to the third. Good. And then on the right, what do I have? 4 to the, what is it?
8x.
Where'd you get 8x? So what's this exponent here with this 4? That's a 1. What do we do when we multiply with the same base? We add the exponent. So this becomes 1 plus 4x. So we have 3 equals 1 plus 4x. So 2 equals 4x. So x equals 1/2. Okay. You all right, Nick?
It's just confusing.
I think it's the hair in your face. I think that's doing it. I think it's causing confusion. Cole's experiencing the same thing. It's the hair in the face thing. It causes confusion. Okay. How about this one? What's the left side going to look like? Yeah, I'm going to add the exponent again, right? 2x plus 4 plus 2x. So that becomes 2x plus 2x is 4x plus 4. And that equals, what? Yeah, 9 to the negative second. Right? So we have 4x plus 4 equals negative 2. It gives me 4x equals negative 6. X equals negative 6 over 4, or negative 3 halves. Okay. Good on that? Okay, 19. All right, it's getting trickier. So we've got 7 to the negative 1 equals 7. Oops, that's not a 7. That's a 4. Right, 7 squared to the x minus 5 times 7 to the x minus 9. So we end up with 7 to the 2x minus 10 plus x minus 9. Okay. Everybody understand that? What we did? Okay, so we have negative 1 equals, let's see, that's going to be 3x minus 19. That means 3x, adding 19 to both sides, 3x equals 18, or x equals 6. Okay. And the last one. Let's see, can I use 4 or do I have to use 2? We can use 4, yeah. So 4 to the 2x times 4 to the negative 2 equals 4 to the 6x plus 18. So we've got the same base, so we have to add them. So this is 4 to the 2x minus 2 equals 4 to the 6x plus 18, which means 2x minus 2 is equal to 6x plus 18. All right, so let's see. I'm going to subtract 2x, so I get 4x over here. Subtracting 18, I get negative 20. So x equals negative 5. Da-da-da-da-da. Okay, so as soon as you finish, upload it to Google Classroom, and then I have a homework worksheet for you to do. Sure, it's different. Yep. You're welcome.
There's nowhere to submit it.
Really?
The practice with
I thought I just put it in there.
I keep refreshing. And I'm not seeing it.
Ah, I didn't save it. Hold on. Sorry.